Hello, hello, hello. Welcome back, Theo. And today we have a guest.
Yes, Luca. Hi, everybody. And let me introduce you to Roberto Bianchi of
Hi, folks.
Spendesk.
Very happy to be here. Thanks for the invite. I'm a great also listener to this podcast. So happy to be here today.
But Roberto, you are a celebrity, but probably not everyone knows. So maybe you can start giving an intro, and then we can jump into this chat.
Yeah. So first of all, I'm not at all a celebrity. I'm working for Spendesk, which is a fintech company from Paris. I work as a staff software engineer there, and I'm also contributing to the open source world. So world of Fastify and other interesting tools. I'm also a heavy fan, let's say, of the whole platformatic world ecosystem and tools that are available there.
Okay. So we finally found one of our fan that downloads our software, Theo. I told you.
Yeah, I don't know who used it, to be honest. So you see.
Now we are only 2,900,999 to go. Find out.
Yeah.
But if you are one of them, comment so that we can shout out to you. But today we are talking about something extremely in trend, but also dear to us, the infamous sidecar tab, which is not the 1990 famous sidecar that you would put on the motorcycle, but it's similar. Something that you put on side of your application and your containers. So where shall we start, Theo? Where do you want to start this chat?
I don't know. So first of all, I think we should be starting by framing why we started adding sidecar over sidecars to our apps. You know, Luca? Do you remember that moment specific?
Sidecar. Well, I know because, to be very honest with you, back in 2012, when I was in my beloved Amsterdam, I started designing this platform, and we kind of like created the first probably sidecar at the time with Nginx. So I know how it started with one, but with more than one, I think, like we say in Italian, right? Gli dai un dito e si prendono il braccio. You give them a finger and they take the whole arm, right? So
I don't know what's the meaning of that in English, man. That's the translation, but yeah.
Well, literally is that one. But I know that many companies, they love, to kind of like abstract the concept of distributing capabilities by kind of like adding all these infrastructure layers, right?
Yeah.
And for example, there's a sidecar for logging, there is a sidecar for authorization, there is a sidecar for secrets, there is a sidecar for basically anything you can think of in a nutshell. So that's how you get the wedding cake of sidecars. But surprise, it's not a happy ending.
One for mesh networking. Luca, come on.
Well, yeah, the famous Envoy. What else?
You can't live without that.
What other sidecar do you use, Rob?
So to clarify, at least in Spendesk, we do not really use a real sidecar per se, so not real, let's say, containers dedicated to, I don't know, doing authorization, etc. But we kind of abstracted that concept using internal modules that associate to those similar goals. In any case, of course, there are, as always in life, and especially in tech, there are pros and cons for everything. So I think this, the sidecars, the pattern started to arise when companies started to use more and more microservices so that at least with a sidecar you can simplify some kind of things, like as we said before, logging, metrics, authorization, and then you have the control plane from which you can decide how to let the services to communicate to each other. The problem is that it abstracts and simplifies some aspects of the microservice interactions, but it comes with a cost, like networking and latency costs, maintenance costs, etc. So as always, you need to balance very carefully pros and cons of those technologies.
Yeah, that's a fair point. And like Matteo was saying, we all remember the good old times of the Envoy, and so the networking one. But talking about sidecars, Theo, and maybe modules. I mean, there are two approaches, right? One that is the Docker layer, or the more physical, between quotes, approach, and there is the more, let's say, softer logical to add modules, right? That you can kind of like import in your application. But maybe, Theo, it's interesting to kind of like dig a little bit into the pro and cons of both approaches.
Yeah, so it's actually interesting. Okay, using modules, okay, is probably one of the most effective way to get started. Okay, you keep building things on top of that. Okay, the problem with having modules is that it's locked into a given stack, for example. Okay, but then, and more importantly though, it's all that logic, all that baggage, okay, is executed for every request in most stacks. Okay, you have all this logic happening all the time, and that adds up pretty quickly, to be honest. And then you have that becomes, in reality, in most enterprise level applications, the time in which your code is actually executing versus all those other ancillary tasks being executed is very small. And in fact, most of the time, the bottleneck is not in your application; it's your infrastructure, which these I consider your infrastructure. Okay, your plumbing and so on and so forth. So all of that sits there. Okay, so I'm not seeing anything different in that topic. Now, on the other hand, people started moving things out, because if I move things out from my application into sidecars patterns, I kept adding them one after the other, and which makes them more reusable to some extent, but at probably a larger distribution cost and at a larger execution footprint. So tricky. Okay. The main advantage for that often for me is that they can be multi-stack very easily.
Well, yeah, the physical, let's say the Docker is definitely multi-stack, because I imagine that they expose HTTP endpoints,
Yes.
or whatever, RPC endpoints, and they can be called. But there is also something else, right? That I think the physical one makes it very measurable and very enforceable versus the modules, right? How do you guarantee, for example, that because you and I have been hearing a lot about the so-called templating, right? But how do you guarantee that application A and application B, they both implemented they both use the same modules?
You can't.
You don't. You can't, Luca. It doesn't work. Okay, it really doesn't work. And in fact, it's even worse than that. Okay, you take a given stack, okay, and then that stack, you get a given template, and you said, oh, I've done the whole template for my whole organization, so every new project is going to follow this. And then you have still 20 completely different applications that have nothing in common.
When you are lucky, you have 20, because
when you are lucky, yes, when you're lucky.
Yeah, you have like a multiverse of versions.
You have a multiverse of those implementation of that template, because once it's generated, then that gets lost in the wind.
And
Totally
how do you also distribute updates or patches or anything? Because many
That's
people,
again, sorry to interrupt. That's again super tricky. Of course, if you, let's say, abstract the logic very well so that the logic is handled inside different dedicated packages, it's a bit easier, because at least you can say, okay, just bump the version on your package JSON and you will have the updates. But at the same time, you cannot guarantee that every service and every team will do that. So you either do that manually, which is error prone and takes time, or let's say it's not a really deterministic approach.
Yeah, because I mean, many people would say, oh, but it's easy, I have a package JSON for that, right? And so what you do, you basically just do the reference and then update it, easy peasy, right? But that's not so easy, also because when you template, most likely you scaffold, right? So you kind of like generate some code. It's not just a matter of the package JSON. That, I think, is a myth that Theo, probably we should have like one of our banter on this more in depth, talking about the madness of templating and
we should look at, I have been having that discussion so many times. We should really have a long conversation about how that is absolute madness.
Yeah, I have a lot of war stories from
like I've not seen any of that working. I was recently, last week, I was in Berlin, and I had a long conversation about this topic, a half an hour long conversation about this topic, about how bad this thing is. And I was not able to convince the person I was talking to that was a really bad.
Yeah, unfortunately.
Right. It's like I'm seeing people wrecking themselves up for no particular reason. So I don't know.
Yeah, and then, but there are, these two school of thoughts, right? The school of thoughts of like the templating and the one of the sidecar, right? Which, to be honest, I was chatting with somebody about all those sidecars and how they implemented the scale and blah 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 blah. But at the same time, it's kind of interesting when people say my need is to unify the way everywhere logging, for example, is done within the organization, right? I don't know. To me, it's kind of like interesting that that's one of the use cases, right? And say, but sure, but behind the scene, you have a logging platform. So why don't you just standardize on that instead of adding? Because like every layer that you add, like you were saying, latency. You add more X of reliability, right? Because you had an extra layer, right? So automatically you have a factor of resiliency that goes by.
Yes.
So I don't know if that's the correct pattern to apply everywhere, especially when you use HTTP, right?
I don't think HTTP or gRPC or whatever matters.
Whatever you have a protocol in between, because you used to do anyhow.
Yeah, the problem is the moment you put a sidecar on that specific thing, you need to do some form of remote communication, okay? And some form of remote communication, require the use of frigging TCP socket.
Yeah.
Well, Quick is not there and stable and used everywhere. So maybe in the future we will be able to use UDP, but that doesn't change much on the discussion that we're going to have right now. So yeah, that is the problem. So I don't know what we can like. You have the remoting and you have the communication, and then it sits in between. Now you might, like a lot of people said, but it's just a TCP socket. Okay. Well, it's not just a TCP socket. First of all, the number of sockets in the system is limited. Okay? There's a total limit on the number of the count of them. Okay. Also, and there are also a soft limit. Okay. Sorry, another limit, which is the amount of memory that can be allocated for them in the kernel. This is a much more, and this is on the actual physical host. This is actually, sorry, on the host of your container. Might not be physical, so it might be a virtual machine. Doesn't matter. On the host operating system. Now, all those sockets adds up. Okay. Now, how much a socket can take? Well, you know, if you know about TCP, you know that there is a transmission buffer and a reception buffer. So TX and RX, and both of them can usually be between 4 and 32 kilobytes. This is the window to avoid retransmissions and things like that. So it's useful that they are bigger. The bigger they are, usually the faster your transfer gets, but the more memory your system consumes. Now, if it's 32 kilobytes, okay, and you start having hundreds of thousands of connections, now that it gets getting bad because that number goes up. And you might exhaust, and the kernel usually by default has a limited amount of memory allocated for this to prevent incoming sockets to swamp your system. But the result is, once it's out, you cannot allocate any more sockets. So you're done.
And
you are cooked. And there is also a limit for each process, as well as a limit for the host operating system. So you have these two levels of limits. And you, the moment you start allocating a lot of these TCP connections for everything, you might exhaust all the things. And now you see, oh, but I put more load into my machine, but I'm not getting any output. Well, you're out of sockets. Okay, you're out of memory. Like you need to monitor. These are key important metrics for your system that almost no one is monitoring anytime.
Yeah, and plus you have the nature of node, right? With the beautiful Pac-Man effect on memory, plus the fact that when you squash layers, your limitation of memory and CPU is still associated to the container. So you can squash under layers, but if you assign 4 gigs, are still 4 gigs. And as you know, node is gone up as much as
all of them.
Right? So
go ahead, Luca.
No, please.
I was asking Roberto something. So
go. I was also going to ask him something. So
okay, so you go ask Roberto something. You go ask Roberto.
No, okay. I start, then you probably tap in, or maybe it's the same thing. Then great minds think alike. Rob, I mean, we had this kind of like generic talk, but I think everyone is interested to know something more about your real life experience, right? So tell us something in your experience of like running logging and all those kind of things, probably in your real life deployment at Spendesk, and a little bit the findings that you had in this journey.
Okay, fine. So I will try to be, let's say, to give a broad view of what I had as an experience on that side, also my previous job experiences. What I've seen so far is that even though you have maybe not a lot of services interacting to each other, of course, the effect is worse if you have, I don't know, 100 microservices communicating to each other. When you use an approach like that, so sidecar pattern, either logical or physical or both, you have a big developer experience problem, because you need, for instance, to start a lot of different Docker containers just to be completely sure that you can debug your whole flow from the beginning to the end. running tests, real tests like integration tests between different services is very complicated. And of course, also, let's say, organizing and handling the infrastructure side of things of such an environment is not so easy. And as we said before, inter-service communication is a nightmare, especially if it's required to have, let's say, secure communication between services. So to be in kind of a zero trust network, because you cannot just communicating with plain text, let's say, using just HTTP. You need to add extra security layers on top of that, and every layer introduce a cost, especially in terms of performances. So yeah, probably it's as we said, as you said multiple times during your podcast, you are solving with such an approach an organizational problem, which is good because you can have different teams completely independent to deploy, etc. But this comes with a high cost, especially in terms of maintenance and latency. So yeah, at least this is the experience I had so far. As I said before, pros and cons.
Yeah.
So, but I have a question for Luca, but also for you, Rob. So if you have built a microservice network, okay, which company do not require, full encryption and secrets and, not zero trust between services? Like
I mean, it's kind of interesting, right? That back in 2018, no, probably 2019, the word zero trust became extremely popular, right? And before then, nobody really kind of like cared about zero trust. So it's kind of interesting that it became trendy. So on one side, to answer to your question, Theo, in my opinion, there is a lot of social pressure into zero trust because things were kind of like developed, let's say, in a different way without really caring about zero trust in the past. Truth is, yes, you are completely right. In a distributed system that is non-homogeneous, I think zero trust should be a foundational piece. But I think what we are going back to argue is probably usually the same point. If security is so important, why do you as an organization force yourself to conform to a trend of having microservices when you could actually have top security by having a single artifact? Because then you don't go in the network. The problem is always the network, right? And I think the myth that we are trying to kind of like demystify is that deploying single unit of operations is a smart idea.
As much as you can, yes, you should be doing that, yes.
But then you always need to look, I think, of the unit of value instead of unit. I think that back to what Roberto was saying, right? There is a lot of misconception on what is what in this organization. And then there's the orthodox, or most likely the Stack Overflow definition. Well, nowadays you say what ChatGPT or any AI tells me. And then everyone follows that train, right? In my opinion, there is a different kind of analysis, right? When you look at those kind of systems, especially when you look at how to distribute those capabilities and what kind of like problem and unit of value you are really kind of like solving on one side and creating on the other. So, I mean, to your question, we're all back to the usual point there. I mean, why building microservices?
Yeah, no, just to add something on that, I totally agree. And at least from what I've seen in the past, also interacting with other engineers from other companies. In some companies, they even have the concept of nano services, like you have one feature, you have one service. And I mean, this seems crazy because, again, as we said before, services have been started to rise as a trend because so that teams could have more autonomy in deploying and being autonomous on releasing new things for their own service. But yeah, if you start to have thousands of microservices, then good luck to handle all of them, right? And probably the thing that makes more sense is the new concept, let's say, of a modular monolith. So something that can interact inside the same process and be deployed as a monolith, but you can develop it in a more modular way so that you give the team the flexibility to be autonomous on creating their own piece. But at the same time, on the infrastructure side of things, etc., you can deploy it as a unit and single piece of code, which was, as we worked in the past. I mean, I started with PHP and other kind of languages, and at least it was easier to handle that part.
Because, Rob, correct me if I'm wrong, right? When you and I met the first time, you were working on Magento, right?
Yeah. When we met the first time, I worked with Magento. Yes, Matteo's so happy about it, and I also have some certifications.
Oh, you have some certification. Wait a second. Does it come with a Highland tattoo on the back, on the shoulder?
Yeah, probably so. A tattoo.
It's.
I mean, I think that's probably where, Matteo and I were kind of like going when we started the kind of like rethinking about modern system. Because, I mean, if you look at Java or PHP or even Ruby, because Ruby definitely, I don't think it was modular. DHH is gonna for sure disagree with that. But the big advantage is that you have the command and control by the single artifact, right? So because you have a single point where everything falls, you can enforce all those kind of like capabilities, right? And if you think, for example, at Magento, or if you think like PHP, if you think about Java, right?
Yeah.
You have this kind of like single point of aggregation where you have logging, you have all your security, you have X509 for cross-point communication, and it was all single center handle, right? Now we have, I think we jumped way too fast in the world of distributed system without counting that distributed system are very complicated to be designed on first point and managed on the other.
Not really. I don't think that's the problem, Luca. I think in most of the cases, people started doing distributed systems as an act of hubris, okay, without having enough understanding of what was happening. We have stats on this, by the way, so you can say we have interviewed so many people, and when you go and says, "Oh, what do you do? Oh, you do APIs." Okay, so you know about distributed system. Okay, so let's talk about Lamport then, and then.
Yeah. But also when you think about actor model and event-based communication, like
there's those things that all those things are not like most people don't treat like they do. They implement API. They've been thrown to building APIs to communicate with things, and they don't really understanding without any real understanding how the system would actually fall and fail in case of problems. So.
And it's kind of interesting that now in this world of AI that basically is in everything that you talk, there's always AI. Still, I think the majority of engineers do not realize that basically we're talking about state mutation, right? And back to one of our banter, right? And our chat is just, it's kind of interesting. The world divides between fire and forget communication versus state mutation communication.
Yeah.
Like there are not many things. So when people say, "Oh, I have an event-based system," I said, "So you have a stateful system, distributed stateful system.
Yeah.
What do you mean? Well, I mean, if it's event, it means that you are trying to mutate something. No, that's how the microservices communicate with each other. Okay, well, next, because it's so fundamentally easy, right? But Rob, let's do a little bit of self-promotion because why not? So you came to the same conclusion as us, and you kind of like took VAT, our application server, and ask yourself a question and try to answer it with an experiment. I was wondering what was going through your head when we brainwashed you with this theoretical science dessert, and then what led you to kind of like try it? Because I think that's interesting for the people listening to this.
Sure. No, this was a super interesting thing to investigate, because as I said before, it's now different years that I work in such kind of approaches in microservices world, with all of the limitations that we said so far. And so once I've understood how that works, and the fact especially that you can let different, let's say, services or packages to communicate to each other inside the same process, then I said, well, let's try this thing and let's see some benchmarks and see what are the differences between the typical approach in the microservices world. And so, yeah, I tried on an open source repo that I created, which is called VAT POC, available also on my GitHub. I tried to replicate a very simple setup with a few services that are communicating to each other through IPC, so inter-process communication through VAT, standard TCP, and with mutual TLS communicating to each other. And I mean, results are as expected, but still mind-blowing, because we are talking, for instance, of a difference in terms of average for the latency, about 250 milliseconds with inter-process communication, and with TLS it's more than 1 second. And same for other things like the number of requests that you can handle using such a system, the throughput, etc. And also another very important thing is that with such a setup, you have basically all of your codes, and you can debug your codes because you have everything in one single piece of unit of code. While in the typical microservice approach, you need to start multiple containers and blah, 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 blah. And it's way more complicated to debug things, test things, etc. So yeah, results were absolutely phenomenal looking at that. And on top of that, you can have very easily metrics, OpenAPI compatibility, so see the open APIs of your services all together. And with another tool like VAT admin, you can also see with a graphical UI what's happening in your VAT process. So see real time the metrics like CPU usage, Node.js, memory heap, etc. live on your system, on your local. So for instance, you can run AutoCannon and see the effect live on your different services. So I would say that to me, this is the future of how we should build services in modern companies, let's say, because this can save us time regarding, as we said before, inter-service communication, debugging, developer experience that is enhanced, and a lot of other cool features.
Yeah, and I think one thing that you kind of like experienced, right, was this fact that unifying basically VAT and IPC communication, right? You can actually achieve the same as your sidecar, in terms of like distribution and so on, but without the paying the cost, the network cost of anything else associated, right? Because you could, what you were experimenting basically is like you can build even a service for login and then you put it into VAT. But this one will be an IPC. It will not be a network, a real network communication.
Exactly. And on top of that, since you are not over the network, it's secure by default because, of course, you need to protect your public layer, the layer interacting with the outside. You can also have different VAT instances, so assembling different services depending on your needs. But the nice fact is that you can decide later on if you need to really abstract the service outside or not. So you don't need to start from the beginning thinking about, okay, let's create the service A, B, and C. You can put all together and then analyze the data and then decide later on. This is something super cool because otherwise, if you are in a microservice approach and then you want to unify things, well, it will be way more complicated when things are in production, etc. So, yeah, as I said before, I think this is the future and this is how we should approach such problems in the future. Yeah.
Yeah, we also wrote an algorithm for that, by the way, for the last problem that you described. That is part of our brain. So the intelligent command center is able to detect based on traffic and usage, how basically services can actually be reshuffled within the network, right? That's basically one of the cognitive overhead that basically people solve by designing in micro or nano. Because if I design everything super small, then I can assemble it later on, and then 3,000 replica sets later, you're still there with your nano stuff around.
Yeah, and they burn money. You literally taking money and burning it. Okay?
Yeah, plenty. And the other kind of like interesting angle in what you say, Rob, is that there's not only this design kind of like pattern, right? But think about taking 3 layers in Docker and squash them into a single image, right? What if one of these layer is causing problem? All the container has the fail restart policy, right? It's a container level, it's not a layer level policy. So what happened is that you're going to restart the whole container when maybe just the logging fails or maybe whatever other side. And you can implement what you want, like back fracturing, circuit breaking, but it's so complicated and your container will never restart. With that, it looks like a promotional ad, this one. It looks like a sales pitch, but it's mostly kind of like this kind of problem. With that, what we solve is that all these things are running in worker threads, and ergo, we can make them auto-healing. Or we can decide to, back pressure it and wait that the thread is back in a healthy stage. Because the cost of starting a pod is extremely high. It's not cheap. Starting a pod is not cheap at all. And so that's basically where I think is also kind of interesting is you can have all this layer that they run separate, but at the same time, they don't introduce any more reliability issues, but they are actually kind of like they can be on and off the field and so on and so forth. So that's kind of like one of the key advantages in the scenario that you described.
Absolutely. And I would also like to add that, especially nowadays, data is what is the most important thing. And with a system like that, you can access all of the data, all of the benchmarks, all of the real statistics about how your services communicate with each other, what is the most used service and stuff like that. And then you can decide based on data and no longer based on people opinions. So you start to decide based on data. And I think this is one of the great wins. Plus, as we said before, starting so many pods and services and making them communicating to each other, even if you are super good, you work, I don't know, at Google, you make things perfect and everything works fine, it comes with a cost. And we are no longer in an economy, in a tech market where we can say, okay, let's just spend some more money. I would say that nowadays people are way more conservative on that approach, and they prefer to save money. And if you have a super complicated and you have microservice approach with a lot of pods, you absolutely need a lot of money to run this whole infrastructure. So there are also, let's say, this is also another thing to consider in your company.
Yeah, and yeah, I fully agree with you. I mean, as a startup, we perfectly know the world of money conservation. That's how where we live. But for us, you know, and there was actually another fundamental kind of like very provocative thought, right? That you know we were in the midst of cloud native, right? I mean, how many times have you heard it? Plan.
Serverless also.
Serverless. It is actually one of the most listened bands, one of serverless, and after Kafka and microservice, that they kind of like beat the entire universe, because as soon as you say Kafka, it's like you know.
You should do another one on Kafka, Luca.
We should do it every week on Kafka. Just like the Kafka band. No, jokes aside, I think what actually was interesting for us was to try to change the perspective and say, what if we flip the equation and we make it act native? Why don't we put the application at the center of this, and we kind of like separate the developer world from the operation world, and we create that glue in between, right? That simplifies on one side the whole telemetry and the whole, if you may, introspection and kind of like reliability aspect, and on the other one, we give it as a given to develop. So we put at the center the value of the app first. That was probably the most provocative thing that we kind of like saw by, you know, seeing this space for a decent amount of time. And we are not going to reveal how old we are, Matteo and I. But
come on, really? Aren't we? Is it? I think it's public information, at least on me.
I don't know. Everyone thinks we're still very young, like 27, 28.
I hope so. Like, really, I love it when people says we are 27, but maybe just 30. Yeah, we're not sharing how old we are.
I thought 25.
Like typically, what my answer to that point is, I answer when somebody says that. Well, I had a page on GeoCities, so I've been on the net for a long time now. Okay, which it's
the old good GeoCities.
That should show, you know, how old I am. Like
the father of all platforms as a service, right?
Yes, come on, GeoCities. It was fantastic. Those days was fantastic. Yeah.
Rob, did you have a page on GeoCities?
No,
Rob is too young.
No,
Rob is too young. Rob is too young. You see, Luca, Rob is too young.
My God,
but I use the IRC, so Internet Relay Chat.
You're not that you're probably a little bit older than, but not as old.
Not as old, but to start using Linux, I joined that kind of very fancy chat system.
Oh, okay.
That was a must, you know. That
you couldn't.
And when I was super, let's say, dumb and young, one of the response was, okay, to fix every problem, run rm -rf/.
That fixes all your problem.
Yeah, you know? Absolutely. I started to see very fancy phones in my system, etc. It was a very fun experience.
I need to send you, Rob, a beautiful talk from Brian Cantrell, my inspiration, where he actually was talking about rm -rf/ in different let's say, operating systems, and he was describing how Solaris kind of like it's kind of super interesting. I need to send it to you. Probably I will post it as a comment so that everyone can watch it. And with all the times that, by the way, that I mentioned Brian, I should ask him to send us a t-shirt or to at least be in this podcast one. But yeah, I think we are almost at time, Rob. And Theo, do you have any more interesting stuff to ask Rob?
I have a data point. Okay. We do have two things in that. One is we implement a mesh network on top of HTTP. Okay, on top of the new node HTTP stack. So fetch works. You can communicate between services, but it has the full HTTP semantics. Okay, but we also provide the lower level mechanism. Okay, that just allows for message passing with normal, to some extent, name. Okay, and it works really well. So, and it's part of our internal system, but we have exposed it, and you can use it yourself. And if you want to, that is even one level faster if you want.
And Theo, just because we spoke about it last week, we also implemented a way to do cross-worker thread communication.
Yes, that has always been there, and has always been possible. So
yeah,
pretty cool.
But now it's exposed and available. It's
yes,
cool
yes,
feature,
exactly.
actually. That's a very cool feature. And
Yes.
Rob, is there anything else you want to add to our chat? As you can see, it's three formats. Here we don't have an agenda.
No, another bonus point that I forgot to mention before is that I mean everything is written in JavaScript with that, so you can see the full request flow, and you can debug it and see what's going on inside your request, etc. And with other kind of setups using Docker and Kubernetes, etc., it's way more complicated to debug such things. So this is, as a developer, I would say this is also a great bonus point because you have more control. You can understand way better what's going on in your application, and it's absolutely important. So yeah, another bonus point of trying that in your own architecture.
I hope all our listeners will do it, especially following your great results, Rob, because we love what we build, right? For us, we'll not build. At the end of the day, we are here to try to solve real life problems, but at the same time, we generally love what we're building, is because we put kind of like a lot of thoughts and a lot of provocative views. And one other thing that is super interesting is when people outside of us, they're really trying it and they're seeing value. That's where, for us, is the top. Like we saw other users of a very large scale that we cannot name yet, but as soon as we name them, it will be interesting that they saw massive things with Draft. And many others, right? So that for us, it's very impressive to see that is going somewhere, right? That we are, and that at least we were not the only one to see the world in a certain way. So that's very important. And Rob, I want to thank you for being here today. In case you were wondering, the t-shirts are in the making, so you're gonna get one next time.
Great, love it.
Yeah, that's a little bit of fun.
Finally, Luca, you say finally. I want my Northern Banter t-shirt.
Yeah, I will bring it to you next week. So I will spend.
Fantastic. Okay.
Just don't make it dirty because I'm going to bring one. So that.
So I need to wash it every time. I need to wash and iron it on a 1 week cycle. Come on, that's hard.
Basic hygiene, I would call it, but that's but then you can redefine it as you want. Anyhow, Rob, thanks for being here. It's been a pleasure. Hope to see you in our chat more. And till next time, I would say Ciao everyone. Ciao Teo. See you
Bye.
next Wednesday.
Bye, guys.
Thank you.
Ciao.
Thanks a lot.